All right, today we're talking about primary lateral sclerosis, and this one, it kind of breaks the mold for motor neuron disorders. Its defining feature, it's not weakness. It's this overwhelming progressive stiffness. So let's dive in. When you hear motor neuron disease, your mind probably jumps straight to something like ALS, right? And we associate that with muscle weakness. But what if a disease just flipped the script entirely? What if the main problem wasn't a loss of strength, but this intense, creeping stiffness? Well, that question right there, that brings us to our topic, primary lateral sclerosis, or PLS for short. Okay, so what is PLS exactly? It's a pretty rare disorder, and it's all about that progressive stiffness and spasticity. And the reason why is super specific. It's because of the degeneration of something called upper motor neurons. Now, to really get what that means, we've got to take a look at how our bodies handle the whole chain of command for movement. Yeah, think about it. Every single move you make, picking up a cup, taking a step, it's like an order coming down from a head office. Your nervous system has this really clear, very strict hierarchy to make it all happen. So here's how it works. Step 1, your brain decides, hey, let's move. Step 2, an upper motor neuron, let's call it a UMN, grabs that command and acts like a messenger, zipping it down the spinal cord. Then step 3, the UMN hands off the message to a lower motor neuron, an LMN, and that's the one that plugs directly into the muscle and says, okay, contract. It's a simple flow. Brain, UMN, LMN, muscle. Done. And a really great way to think about this is like a company. The UMNs, they're the managers. They're sitting in the brain, giving the orders, supervising the whole operation. The LMNs, on the other hand, they're the workers right on the factory floor. They're the ones who directly connect to the muscles and do the heavy lifting. Now here's the key. PLS is a disease of the managers, not the workers. And this is where it gets super interesting, because these manager neurons, the UMNs, they don't just shout go. A massive part of their job is actually to regulate everything, to smooth out the whole process. They provide this inhibitory balance. They're constantly telling muscles not just when to fire, but how much to fire, and just as importantly, when to relax. They're basically the reason your reflexes don't just go haywire all the time. And that role, that regulatory braking system role, is the absolute #1 key to understanding the huge difference between PLS and its much more famous cousin, ALS. Okay, so let's make this crystal clear. The crucial point is this. In PLS, it's only the managers, the upper motor neurons, that are breaking down. In ALS, it's both the managers and the workers, the upper and the lower motor neurons. That one single difference, it explains literally everything about why these two diseases look and feel so different. And you can see exactly how this plays out when you look at the symptoms. So with PLS, right, the managers are out of the picture. So the workers, the LMNs, are just going wild with no supervision. That's what gives you the stiffness, the spasticity, the overactive reflexes. But because the workers themselves are still healthy, the muscle bulk is preserved, especially early on. Now contrast that with ALS. There, the workers are also breaking down. The signal from the brain just doesn't get to the muscle at all. And what happens then? Weakness, and eventually that muscle wasting we call atrophy. This quote just nails it perfectly. The problem isn't muscle destruction. The muscles are still getting a signal, it's just a chaotic, unregulated, staticky signal. The impairment is all about motor control, which is why you see stiffness, not the weakness that comes from muscle destruction. Okay, so this difference also has a huge impact on how the disease moves forward over time. And a big takeaway here is that the progression of PLS is typically much, much more gradual. So how does it usually start? Often, it begins in the legs. Someone might just notice their walk feels stiff, or their balance feels a little off. Maybe they're more clumsy, or their speech starts to get kind of strained and slow. And notice the theme here. None of these things are about a sudden, I can't lift this anymore kind of weakness. It's all about that loss of smooth, coordinated motor control. And this, as you can imagine, leads to a huge challenge when it comes to diagnosis. I mean, think about it. A patient shows up with these early symptoms. A doctor has no way of knowing for sure that it isn't just the very, very beginning of ALS. So what can they do? Really, the only way to know for sure is to wait and see. They literally have to observe the patient over a long, long period of time. And how long are we talking? Typically 3 to 4 years. Can you imagine? A doctor needs to see that consistent pattern. Only signs of the managers being offline, with absolutely no evidence of the workers failing. No muscle wasting, before they can confidently say, okay, this is PLS. So this whole diagnostic puzzle, this overlap, has actually pushed researchers to think about this in a whole new way. They're starting to see these conditions less as totally separate boxes and more like different points along a single spectrum of motor neuron disease. It's a great way to visualize it. So on one end of this spectrum, you've got PLS. That's our upper motor neuron predominant condition. Way over on the other end, you've got diseases like progressive muscular atrophy, which is all about the lower motor neurons. And smack dab in the middle, that's ALS, the mix of both. They're all connected, they're all on the same spectrum, just hitting different parts of that chain of command we talked about. So you might be asking, why does this even matter? Well, thinking of it as a spectrum really helps make sense of why one person's experience with motor neuron disease can look so incredibly different from another's. It explains that diagnostic gray area, that tricky early phase. It's a way of acknowledging that biologically, these conditions are complex and they overlap. And that brings us to our final thought for today. Seeing PLS as part of this bigger picture shows that it's not just some milder version of another disease. It's its own distinct condition that actually teaches us something really fundamental about how our nervous system is supposed to work. It leaves us with a really critical question, not just for PLS, but for any complex disease. How does understanding the full spectrum, the entire landscape of a condition with all its variations, change the way we approach everything, from research to diagnosis, and hopefully one day to treatment?